M-E-A-N for mean.
Maybe that's what I was thinking of.
Mean?
Yeah.
That's okay, and that's another word for it, right? There's a word called mean. Your book will use it from time to time interchangeably. But the trick with that is there are also different kinds of them. I was actually looking at a student's, she's in a natural resources class right now. And there's something called a mean geometric cross-section or something of a tree. And that's another kind of average. So in this average, you add up and divide by how many there are. A geometric mean is you multiply the data and then take the square root of the data that you have. So that's a different kind of mean for different kinds of applications. This one is the best one for us to use in statistics. So median is not always numerically equivalent to the average or the mean. What is this guy, for those of you who have heard it before? Vivica, please.
You put all the numbers in order and then find them.
Yes, this is, you line them all up in one order. You line them all up and find the actual geographic middle. So that's what your median is. So I guess just like you said it, right? You line up the data in order, yeah? And it doesn't matter if it's up or down. That's totally irrelevant. And then you find the middle. And I kind of think of this as the geographic middle because it's based not on the sizes of the data points, but only on their locations in that row. So, and that's important when we talk about Carly's bias, the potential for bias. Median doesn't have a potential for bias like the average does. And there's a reason for that, and you'll see why momentarily as we start going through some data. So I've already lined these up for you in the data set, so let's go back up. Oh, you know what, I forgot to hit record on that, didn't I? Is it recording? Oh, it's going, good, good. I'm trying to be cognizant of that. So let's go back to our data set. You know what? No, yeah, I'll leave it with this. I like to write on a board, but I can't do that now because we have wonderful notes up there. So, which one's in the middle? 4 and 5? 4 and 5? Well, how many do we have again? 30. So it's going to have to be in 15 and 15. So 15 from one end, 15 from the other. So what we could do this is we can cross off extremes and work our way in. So we could cross a 0, cross a 13, cross a 0, cross a 12, cross a 1, cross a 10, and so forth, yeah? And that's nothing wrong with doing that. But it's probably easy. You know what, let's do that. So 1, 2, 3, 4, 5. Lower 5 are gone. Upper 5 are gone. And you see what I just threw away? I threw away the top and bottom 5. I don't care that 13 is 5 bigger than 8. Those are just the biggest 5 numbers. They're gone now. Now throw the next 5 away. Okay, they're gone. Next 5. Okay, they're gone. So now I should have 5 left on either side, I think, right? If we have 30 altogether. Now I lost where I was.
On the 3.
On the 3, thank you. On this 3?
First one.
This one here. So 1, 2, 3, 4, 5. That would give us 15 altogether. And then, where was I over here?
6.
5. 6. So 1, 2, 3.
No, you started with
I had wrong.
3.
I got an easier solution. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Boom, there's 15. Which means if I go in 15 the other direction, I'm going to end up right there. Which means here's 15, here's 16. So technically, that's the middle. So what do we do now?
Add the 4s and divide it by 2.
Exactly, just call it 4. Call it whatever's between these two. A lot of times it's the same number anyway. If it's not, that's totally fine. If it was 4 and 5, just call it 4.5. So that's the middle. This only happened because why? Why do we end up between 2?
Because there's even number.
Because there was an even number of them. If you have an odd number, you'll actually land in the middle. And that's okay. We'll get to that too at some point.
That's why they call it the odd man out.
The median would be directly whatever. So let's take one of these out. This is a great question. Take the 13 out for a minute. Pretend for a moment it's not there. So now we have 29 data points, right? So that means I go in 14 and 14. That cuts out the low 14 and the high 14, and the middle is going to be the 15th one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 14, that's your median right there, because there's also 14 right there. But because we have that 13, we have to move a smidge over because we added another data point.
So then what would the number be?
Just 4,
Oh.
because it's halfway between the two 4s, which is still 4.
Oh, okay.
Yeah, so whatever these two numbers are, if you have 2, just average them. So our median number of keys, let's keep track of this. Our average number of keys was about 4.7, yeah? Our median, I'm going to call that MED with your guys' permission. There's a symbol for median too, but it's becoming less and less used as the time goes on. Is 4. Pretty close to each other. Pretty close to each other. Average is a little bit higher. Average is a smidge higher than the median. We'll talk about why that is as we go through, probably on Thursday. Cool, cool. Anybody think right now of why we would care about using a median versus an average? Please, and this is
Jennifer,
Jennifer.
they use it in housing prices.
Why?
Well, in case there's, like my neighbor, he built the biggest house in the neighborhood.
And what happened to your house value? You should thank him.
It didn't do
He
anything.
didn't do anything, you're right.
Nobody wants his house.
Nobody wants
it.
it.
Store had them.
Same thing happened in my neighborhood. I'm on the northeast side of town, lovingly referred to as the ghetto. And this guy he borrowed $500,000, spent $250,000 of his own money, and built this house and tried to sell it for like $1.1 million back in '09. And I just laughed at him. I'm like, dude, you're not gonna get this. He's like, oh, it's booming right now. I'm like, it sure is for the next 5 minutes or so. And it was the first house in Bend I saw with a sign taped, you know, you missed your first $3,500 monthly payment. My heart was like, $3,500 a month, and he missed 3 of them. I'm like, my God. Like $10,000 in the hole for a house you can't sell. It ended up getting sold in the courthouse. That was $206,000. A $1.1 million, well, I guess it's $750,000 investment in resources, not to mention time.
Somebody got a sweet deal.
My friend Steve got a sweet deal. But yeah, but the housing price is a great indicator of that, because the average, Carly, you said it, can be influenced, can be biased. Imagine, this is ridiculous, but imagine if this person who had 13 keys really had 130 keys, right? Instead of 13, they had 130, right? How's that going to affect the average?
It's gonna skyrocket.
Well, it's got to skyrocket, isn't it? Because if we're thinking about the sharing idea, now this person's got more to share. So essentially, we're doubling, I mean, ish. This is going to become essentially 241-ish, somewhere in that neighborhood. And then all those extra 100 keys are going to have to be spread. It's going to go by like 2 or something, 2-ish, 2 or 3-ish per. How's it going to affect the median?
It's not.
It is not going to affect the median one bit, is it? Because the 13 is just 130 now. Which means when I start doing my chop to find the middle, the 130 goes off the end just like the 13 did. It's just the biggest data set, the data point now. That size of this data point has no effect on the size of this one. It's just positional with the median. So the average actually takes into account how large the data is. The median only cares with where it lives in rank, in a ranking system. Does that kind of make sense? And that's exactly why we do use it for house prices, because you can look at if you will, a truer house value by looking at medians versus averages. Like when that house went in, my neighbors were like, oh my God, our house values just shut up. And that's actually kind of true, because they look at comps, and I'm not exactly sure the mathematical magic that gets worked in that world, but they'll say, you know, if my neighbor sells his house for lower than he paid for it, oh, it's going to hurt our house values. And that's true, I think, because of the way real estate averages are figured out. But median-wise, if you're talking about how to fairly price a house in my neighborhood, I wouldn't include that 1.1 million for sale, you know, by owner price as part of the average, because it's making it look like my house is more expensive than it actually is. So yeah, that's something to think about. Median versus average, or median versus mean. Any questions so far? You guys didn't. That's a great point, Jennifer, about the outliers. That's a word we're going to use a lot in this class. Is outlier. Good so far? There's one more that I want to mention. Actually, I shouldn't say there's one more. There's like a dozen more measures of center, but I don't think they're all worth talking about, at least in the beginning. We'll bring them up as we need them. But there's one more that I like bringing up, only because it seems like most students learn it like on the way with the other ones. Mean, median, and
Mode.
there we go. Most of you have heard of this, speaking of mode.
Mode was the favorite
In what way, Nick?
because it was the easiest to understand.
Oh, it's your favorite. I got you. I thought you meant when you hear the word mode, you think favorite. Why was it the easiest to understand, my friend?
Because you just count up how many numbers there are, right?
That's exactly it. Alan, go.
I was going to say it's the one that occurs the most.
It's the highest, exactly.
Yeah.
It's the one that occurs the most.
That's
One of my old students called it the mostest, which I thought was adorable. It's the mostest. I love that kind of way of thinking about it. So let's go back to it here. And honestly, yeah, by definition, the mode is the data point with the highest frequency. Let's write that down. Yeah. It's the data point with the highest. And you know what? Let's occurrence. Occurrence. And in statistics, we call that a frequency. How often something occurs, we call that a frequency.
Which is the most common.
Which is the most common, exactly. That's why I said, if you remember, when we talk about majority and common, I said these words actually can also tie into another measure, which I knew we were going to get to eventually. Yeah, so common and majority actually are better suited to the mode. But this goes back to my point about when someone says the word average. This word average doesn't necessarily just mean this formula. In this class it will. I promise you that. So whenever we have, if I ask you to find the average of something, I'm going to want you to find the average of something using basically this formula. But in the world, when someone says, well, what the average fish we're catching out of the river right now is rainbow trout, they're clearly talking about what? Which one of these three are they talking about? They've got to be talking about the mode. That means most people are catching rainbow right now. Now, chances are I'm not going to say average. I'm going to say most people are catching rainbow right now. Because you're not adding up fish and dividing by fish. That doesn't make any sense. Cut the head off. No, you're looking at what's happening most typically. And the mode does work very well for this. More on that in a minute. More on that in a minute, I promise. So let's go back to our data set. Do we have one? Sometimes you don't have them. Sometimes data sets don't have a mode. When would a data set not have a mode, for example? Vivica, go ahead.
When every point only happens.
When all the data points are unique. Suppose it was 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to whatever, 30, I guess, or 29 in that case. It wouldn't have a mode. They'd all occur one time. Never happened in 20 years of doing this. So, what's our mode? Oh, sweet! We have multi-modes. We've got 4 different ones. 5 different ones. This has only happened one other time in 20 years. Pat yourselves on the back. This is late bitching, as they say in France. Look, 4 1s, 4 2s, 4 4s, 4 5s, 4 8s. That's 5 modes. That's a multimodal data set. Hot damn! Modes. That's freaking awesome. 1, 2, 4, 5, and 6. No, 5 and 8. Look at that. It's almost a mathematical pattern, too. Powers of 2. Sweet Jesus. It's only happened one other time. One other time in 20 years of doing this. That's fantastic. I didn't even notice that when I was typing it in yesterday. These guys, it looks like there'll be 2 for them. Now, oh, go ahead. Go ahead.
Nothing, I just laughed.
No. Oh, good. Please do. You should laugh in math class. It's worth laughing about sometimes. The problem with the modes is, in a small data set, this kind of thing can happen. Not totally crazily. I mean, 2 times in 20 years is not very frequent. But the problem with modes, too, is tying back into Crowley's bias concern. A mode of outliers can pull averages in such an extreme way that you go, wait a minute, maybe we're actually looking at 2 distinct data sets, and they just so happen to be lumped together. And rather than get into that too much right now with 10 minutes to go, I'm going to hold that for next time around, if you don't mind, and we'll come back to that. We'll come back to that idea. Modes are great, but there's not a whole lot computationally you can do with them. Essentially, you do that and you're done. Now, why do we like modes? Again, more next time we're going to see why we like them a lot. Because we do like them a lot. There's a lot you can do with them. But more next time, we'll get into them a little more detail. Good so far? So those are the 3 I want to seriously focus on in this class. And that's fantastic, except for the fact that, what kind of data is this called right here? When I just lay it all out for you like that? Do you remember what I called it? Haley?
Quantitative?
Oh, it actually, very nice. Good, good. You're going quantitative. Beautiful. Quantitative, what kind? Quantitative what? What kind of quantitative?
Discrete?
It's definitely discrete. Because we counted how many keys you guys counted how many keys you had. Very, very good. You guys, perfect answers, perfect answers. Quantitative, discrete. That'll be a good little practice problem for you for your quiz on Thursday, yes. I meant in how I gave it to you. Whereas you gave me all your data and I put it in a big row. I was nice and sorted it for you because I wanted to.
Is it raw down there?
It's raw, exactly. Thank you guys. It's raw. It's raw because I give it to you. I gave you every single data point. It's all sitting there in front of me. Now, that's great. You also very rarely get that in the world. That's another problem. Very often, you're going to see this instead. There. That is your data a different way. That is your data a different way. Can we get anything from this chart? Or I should say chart, let's use the correct term. What are you actually looking at right there? Remember what you call that bad boy?
So 0 to
Well, I like bar graph. Bar graph's fine. I think Excel calls it that. Remember the technical statistical term for it?
Histogram.
Histogram. I don't test on definitions in here, but that is a histogram, so. Good, good. Can we pull any of the measures of center from that? Like we did from the raw data? I have a vote for yes.
You can.
We have a second vote for yes. Let's start and stop this thing
You
again.
could pull them, but